Hello, welcome to the fifth VLecture on the fine-tuning argument. I'm going to briefly talk about the paper expectations. You have now 3 resources up on Canvas. I just posted the grading rubric, so take a look there. That also contains expectations for the discussion board posts that are coming due in a little over a week. Also, there is the writing guide. It's a 2-page document that'll help you avoid certain common mistakes, and I'll also give you a better idea of what I'm looking for. And some just general rules for good philosophical paper writing. And then lastly, you have the syllabus with technical instructions on, for instance, the word count and so forth, and how to submit and all that other stuff. All right, so paper topics, grading rubric, take a look there. The paper topics for this, so I'm kind of expecting things to be a little bit far out in this class. We'll see how it goes. Really anything that we've talked about and looked at in this class, so any of the arguments we've looked at, Anselm we've had Aquinas' 5 ways, you could write on any of those. You could write on Paley's watchmaker argument, you could write on the fine-tuning argument that we'll be talking about today. Lastly, we'll be getting into the problem of evil, which is an argument for atheism. That's where we'll be about when the paper comes due. And all of those will be acceptable paper topics. So you could agree with one of these authors or the argument that we're looking at. You could disagree with it. You could attack premises. You can defend those premises from objections. You have a lot of options with respect to that. If you want to do something that's a little bit more out there, like maybe talk about an argument of your own or something else that relates to philosophy of religion, I recommend that you email me first with a question, just letting me know what you want to do. So that I can help you out there and I can make sure that you're not too far out in left field. Usually people don't have to rewrite their papers, but it happens sometimes when they're just not an acceptable philosophy paper. So please let me know if you have any questions about your paper topic. Again, the fastest way to get a hold of me is just glenn.nessie@gmail.com because that goes through to my phone. Or you can send me a message through Canvas or to my school email as well. All right, good enough for paper topics. The requirements, this information is all over the place already, but here it is again. It's due Friday the 13th by 11:59 p.m. Anything turned in after that may be marked late at my discretion. It needs to be 1,000 words plus, which only works out to be like 2 or 3 pages. Again, anything below that might be marked short at my discretion. It needs to be roughly on topic, and I'll take a lot for the rough drafts. It's rare that I'll dock substantial points on the rough draft, even if you are way out in left field, but you might have to rewrite. That's the main worry. So again, please just send me an email if you're not sure. And lastly, it does not plagiarize, obviously. Just like every class, you can't plagiarize stuff off the internet. What you can do is use any source that you want whatsoever on the rough draft. If it's inappropriate, I'll let you know in the comments, and I'll be commenting on your rough drafts. It'll take me a few days to get those comments back to you. And then the final draft will come due a week after. I believe it's marked July 20th on the syllabus, as it were. All right, good enough for the paper. Let's move on to the fine-tuning argument. So there was no required reading associated with the fine-tuning argument. There is an optional reading. Neil Manson has a really good paper, but it's just a little bit too advanced, well, substantially too advanced for this course. Please, though, if you feel like it or if you want to write on it, it's a great source to look at least the first few pages. So the fine-tuning argument, where we were at with the last VLectures, we've been looking at the design style arguments for the existence of God. And these arguments, they had this certain unique feature to them. They suggest that we can look out at nature and the structure in nature and how everything fits together so perfectly and works together so perfectly, and thereby conclude that this must, like a watch, a finely tuned watch, must be something that was made by a creator. But we looked at a serious objection, a serious flaw with these arguments. Naturalists don't have to accept the claim that we need to postulate the existence of a God to explain the order we see in nature. Instead, we have natural theories in science that do a good enough of a job as they are. So we understand that the size of the universe permits there to be trillions and trillions of planets, each which may have life-permitting conditions. Most of them no doubt won't, but some might. And you ought to expect life to arise in those that just happen to have the right conditions. And so as living creatures, we shouldn't be surprised at all, says the naturalist. We shouldn't be surprised at all to find ourselves in a world where everything works together so perfectly, because complex life can't find itself anywhere but in such a world, right? You have so many options here. It's like we noticed that our die was a 20 side up or whatever. You've played D&D. We rolled a crit hit, and we thought that it must have been by design and not luck. But then we realized we have so many rolls of the die that we're going to get it once in a while. And that's the response to those earlier design style arguments. And that was all well and good. And it looked like the design style arguments were destined to fail as strong arguments for the existence of God, until several decades ago, scientists started asking questions. So to explain the fine-tuning argument, which is the most recent version of the design style arguments, I've got to do a little bit of physics and explain a little bit some concepts from physics. So in the late 18th century, late 19th century through the 20th century, we started discovering these values, these numerical values associated with fundamental physical forces and properties of the universe, like the speed of light, for instance. We figured out the speed of light to a very exact amount. We figured out the mass of a neutron and an electron. Let me give you some of those figures really quick. You don't have to take any notes on these or anything like that. So, for instance, the Newtonian gravitational constant, this is, I think, also in the optional reading, is 6.6742 times 10 to the negative 11 meters cubed per kilogram per second squared, right? So it's a very precise number. C, the speed of light in a vacuum, is 299,792,458 meters per second, which works itself out to be about 100 meters per second. That figure must be off. But it works itself out to be about 180,000 miles per second. The Planck constant is 6.626070040 times 10 to the negative 34 joule seconds. The charge of an electron is plus or minus, or a proton is plus or minus 1.602176565 times 10 to the negative 19 coulombs. The mass of a neutron, 939.57 mega electron volts. There's just a bunch of these figures like this, and that we started figuring out, and there's just these very, very precise numbers associated with physical phenomena. We call these the fundamental physical constants. And this reads up here, if you can't see it, a value associated with physical features of the universe. It is universal, meaning it is the same throughout the universe. They don't change. They're constant, right? So the speed of light is in a vacuum is a constant. The mass of a neutron doesn't vary between two different planets. It's always the same. And so back in the 20th century, physicists started wondering what would happen if some of these fundamental physical constants had been different. What would the universe look like, for instance, if the cosmological constant was stronger or weaker, even by a very, very little amount? And the surprising result from tinkering with these things is that there could not be life. And in many cases, you just wouldn't have a universe. Either it would collapse back in on itself, or you wouldn't have atoms, or you wouldn't have stars. And without stars, all you would have is a universe of almost entirely hydrogen gas. And how you can get life out of hydrogen gas, the scientists say probably not. There's probably no way that hydrogen gas could form by itself a living thing. We're a complex organic creature. We have carbon and we have lots of different chemicals that make us up and that we need in order to exist. So to read a couple of quotes here to reinforce this idea. These are almost entirely from physicists. If the initial explosion of the Big Bang had differed in strength by as little as 1 point in 1,000 to the 60th, the universe would either have collapsed back on itself or expanded too rapidly for stars to form. In either case, life would be impossible. As John Jefferson Davis points out, an accuracy of 1 part in 10,060 can be compared to firing a bullet at a 1-inch target on the other side of the observable universe, 20 billion light years away, and hitting the target. Here's another one. Calculations by Brandon Carter show that if gravity had been stronger or weaker by 1 part in 1,000 to the 40, then life-sustaining stars like the sun could not exist. This would most likely make life impossible. And that's from Collins, 1999. The strength of the force binding nucleons to the nuclei is 0.07. If it were 0.06, only hydrogen could exist, and complex chemistry would be impossible. If it were 0.08, no hydrogen would exist. And that's from Martin Rees. And here's one from the optional reading by Neil Manson. To give just one of the many possible examples of fine-tuning, the cosmological constant, symbolized by the Greek letter lambda, is a crucial term in Einstein's equations for the general theory of relativity. When lambda is positive, it acts as a repulsive force causing space to expand. When lambda is negative, it acts as when the cosmological constant is negative, it acts as an attractive force causing space to contract. If the cosmological constant were not precisely what it is, either space would expand at such an enormous rate that all matter in the universe would fly apart, or the universe would collapse back in on itself immediately after the Big Bang. Either way, life could not possibly emerge anywhere in the universe. Some calculations put the odds that the cosmological constant took the right value at well below 1 chance in a trillion. It's 4 trillions. Similar calculations have been made showing that the odds of the universe having carbon-producing stars, carbon being essential to life, or of not being millions of degrees hotter than it is, or of not being shot through with deadly radiation, are also likewise astronomically small. Given this extremely improbable fine-tuning, say proponents of the fine-tuning argument, we should think it is much more likely that God exists than we did before we learned about fine-tuning. After all, if we believe in God, we will have an explanation for fine-tuning, whereas if we say the universe is fine-tuned by chance, we must believe something incredibly improbable happened. So again, the short of it is that physicists tinkering around with these fundamental physical constants, the numbers associated with them, found that if they had been even just slightly different, you couldn't have a universe that permitted life. So we got just the right ones. And it seems astronomically small. I believe Lee Smolin suggested it was something like 1, I'll write it up over here, 1 over 10 to the 229th power. And if you've done any math, you know how large of a number 10 to the 229th power is. Lee Smolin is a physicist. So what ought we to think? And says the theist, we have a natural conclusion here, that the fundamental physical constants were fine-tuned for the existence of life. And there's a kind of metaphor that I can help paint so that you can maybe see how this argument is supposed to work. Imagine, for instance, you had a classroom and the walls were just covered with knobs, thousands, maybe tens of thousands of knobs or dials, and all of these dials had to be set to just the right place in order for a radio station to come in, a single radio station, and all of them, each and every one, has to be exactly right for that single radio station to tune in. So say you came into the classroom one day and you heard the radio station playing, what would you think? Would you think that I spun the knobs randomly and it just played? Of course not. Of course not. You would assume that I had spent many, many hours tuning and tinkering with each little knob so that the radio station would come in. You would assume that it was the product of design and not chance. Likewise, if you walked into a classroom and there on the floor were thousands and thousands of 20-sided die, and you notice that each one had the 20 side face up, just thousands of crit hits there, you would assume that I or your instructor spent hours and hours arranging all of those dies so that they would be all 20 sides up. You wouldn't just think someone got lucky and dumped a huge bag of die on the floor and rolled thousands of crit hits. That seems astronomically small. And that's the kind of metaphor that theists wants to paint with the fine-tuning argument. Now, a word of caution. This argument is often confused with the earlier design-style arguments by my students. I'll often see them try to explain this argument, and then they'll refer back to that stuff like that I talked about in the last video lecture, like the electromagnetic field and the atmosphere of the Earth and all that stuff. This has nothing to do with any of those facts. This has nothing to do with the physical properties of the Earth, like the electromagnetic field or the fact that we have 4 seasons and water in 3 forms and so forth. None of those things are constants. None of those things are physical constants. It only has to do with these fundamental physical constants. And the kicker here is that these have to be the same everywhere. So in the earlier argument, when we said, with the earlier argument, when we said we have lots of chances for there to be a life-permitting planet, all of a sudden now it seems like we just had one chance to have the right physical constants for there to be life. So it seems like we're back in that earlier boat now, and the earlier objection, at least on the face of it, isn't going to work for this argument. So here's the argument really quick. I'll read it to you and make sure that you can actually read my handwriting once again. So fine-tuning argument. The physical constants have the values necessary for there to be life. And that seems obvious, the fact that we can be having this conversation or that you can be watching this video seems like this must be true. The physical constants just do have the values necessary for life. 2, the likelihood of this, of 1, that they would have the life-permitting values, given naturalism, is very low. And so naturalism, I haven't talked about that much. Naturalism is the view that the universe arose according to purely natural processes, that it wasn't the result of divine or intelligent design in any way. Just natural processes is what explains or adequately explains the universe we see. And so premise 2 says, look, the likelihood of naturalism, that view, is low given this fact. It means that we just got lucky with the fundamental physical constants. And then we have to, it seems like we should say something about this ridiculous amount of luck. So 1 over 10 to the 229th power, according to Lees-Mollin, is the chance that we would have a universe that permits for there to be stars. Right? 3, the likelihood of premise 1, the likelihood of this, given that the fundamental physical constants were fine-tuned, is very high. That seems reasonable. If there's a fine-tuner out there arranging all the knobs to the fundamental physical constants, as it were, to be just right, that's not a surprise at all that they're just right for life. It makes perfect sense. Premise 4 here says if the physical constants were fine-tuned, then God exists. And the idea behind premise 4 is what else could fine-tune the fundamental physical constants of the universe? What else could be, who else or whom else could be responsible for the fact that the neutron has the mass that it has, that light travels at the speed that it does, and so forth, right? So an objection to premise 4 says, oh, no, I accept that the fundamental physical constants were fine-tuned. I just think that something other than God did it, whatever that might be. And then 5 is the conclusion here. And the conclusion says, so it is likely that God exists. And notice that this is a conclusion that merely purports to establish the likelihood of something. Similar to the earlier design style arguments, it isn't supposed to be a proof. It isn't supposed to show beyond any doubt that God exists. It's just supposed to make it more likely or more reasonable to believe in God. And so if you want to say, well, I can accept this conclusion. I accept that it is likely that God exists. But, it's not proven, so I won't believe it. Then it seems like you're committed to an irrational position. You're accepting the likelihood of something, that something is probably true, and at the same time maintaining that it's false. That seems like it's irrational on the face of it. So an objection to this argument seems to have to be something that would object to premises 2, 3, or 4. Premise 1 seems like it has to be true. Premise 2, an objection to premise 2 would be one that says, look, these are the physical constants we should expect given naturalism. There's something that's gone wrong in our reasoning when we say that we just got lucky if there's no God to fine-tune things. An objection to premise 3 seems like it might be a little weird. We'd have to say that that this isn't the sort of universe that we ought to expect. If there's a fine-tuner out there, we should expect something else, right? We should expect one without life or something like that. Theist doesn't want to accept that for sure. So that's our argument. Again, I want to kind of leave it up to you to find objections. This is a great argument to use for your discussion board post, and I'll just leave it up to you to find an objection to it. It's not there are plenty of objections out there, so please have a look. And that's it for today. Again, if you have any questions about this argument or about the paper, please send me an email, and I will see you next time.